Hello everyone, it's me Aizuneka, and today I'll be presenting about our project research entitled Social Networking. So this project is about social networking among students. Our population scope is from College Marakulim Committee that consists of students from prior SM, FIS YTP, and also MKPM program. In this project, our sample that become the respondents are the students themselves, and we have decided to take 50 respondents as the sample size. We have come up with 4 problem statements regarding our research project. So first is how the students communicate with their friends by using social networking. Second, is social networking better to communicate with their relatives? Third, how must the students spend their time using social network? And lastly, how can we combat the addiction of using social network? Our group project is led by Fadila, Silmi as assistant, me myself as editor, Muaz and Edwin as our main data analyst. So now, let's move to the next parts of my today's presentation. Our first finding and data analysis is based on the first question in our questionnaires, which app is the most convenient for you. So we have 6 total of answers, which is TikTok, Instagram, WhatsApp, Line, Twitter, and also Facebook. We have received a total of 60 answers from students, and a bar chart has been constructed based on the answers collected. So why do we use bar chart to represent our data? This is because bar chart show the frequency counts of values for different levels of a categorical or nominal variable. Mode, which is the number or event that occurs with the highest number of time, in other words, with highest frequency, has been determined from this data. As WhatsApp is chosen the most by students, we can conclude that WhatsApp is the mode of our data as the most convenient app daily among students.
Okay, now I will explain to you how stem and leaf diagram works. So this is from the question, the usage rate on social networking in daily life. So the most important thing in stem and leaf is the key itself. So in this key, it is written that 3/0, which is equals to 30. So this shows that one of the respondents in the questionnaire had answered the rate is 30. So that same goes to the other kind of data. So for this, stem is 10 and the leaf is 0, which indicates 100. So that's only the concept of this stem and leaf, which is, it really depends on the key. So next we are going to describe what can we extract from the data. So here I had concluded the data from the Microsoft Excel, and this is going to be shown in the form of mean, which is the formula was x bar equals to sigma fx over n. So the answer will be 71.58. So the next one is standard deviation. So standard deviation for ungrouped data will be like this. So with the help of this diagram, only substitute the value. Okay, so this is the standard deviation, which is you just only square root the value of s square. Okay, therefore you will get the value, and also the standard deviation is to 5.55. Okay, next we are going to look at the coefficient of skewness. So for stem leaf, the easiest way to look at the skewness is from the data itself. So as we can see, most of the data is concentrated at the number 8, the stem of 8. Therefore, it is shown that the distribution is skewed to the left. Okay, next we are going to look at the quartiles. So we are going to use the formula S equals to n times k divided by 100. So k can be any integer, which refers to the percentile itself. But for quartile, the numbers are fixed, which is the first quartile is k equals to 25, the median, which is q2, is equals to 50, and the third quartile is k equals to 75. Therefore, by using the 3 number of k that I had said before, so for q1, 50 is the number of data provided in the stem leaf, and 35 is the first quartile, divided by 100. Therefore, we will get 12.5. So 12.5 is not an integer. Therefore, we are going to look at the 13th observation, which is at here. Therefore, the 13th observation will be 60. So for Q2, which is the median, So 50 times 50 equals to 25. 25 is an integer. Therefore, we are going to also look at the 26th observation, and we will divide those two numbers with 2. Therefore, the 25th observation is 75 and 26th observation is 78. Therefore, 75 must be added with 78 and divided by 2. Therefore, you will get 76.5. And the last one, which is the third quartile, the answer is 35.7, which is not an integer, and we are going to look at the 38th observation, which is 80. So the third quartile is 80.
If we want to construct a box plot, we have to find 5 points, which is first quartile, second quartile, which is our median, third quartile, and lower inner fence and upper inner fence. So we have to use a formula, which is S equal to N multiple K divided by 100. So N equal to 50, because the total of our data is 50. K is 25 because it is a first quartile, and we get 12.5. So we have to choose the least integer greater than S. So 13. First quartile is 23. For the median, we have to use K is equal to 50, and the third quartile K equal to 75. So we get the median 32, and the third quartile we get 47. To find lower inner fence, we have to use formula first quartile minus width 1.5 multiple with IQR, which is interquartile range. So we have to substitute. The answer is negative 13. And the upper inner fence, we have to use the formula. So we substitute the value, so we get the answer is 83. And the minimum value is 3, and the maximum value is 16. We can construct the box plot. First, we have to draw the middle area, which consists of minimum value, first quartile, second quartile, and third quartile, and the maximum value. Which draw a line, which is a dotted line, which is a lower inner fence, and the upper inner fence is 83. So next, we will discuss about measure of tendency. So this is the table that I construct, which consists of fx, x squared, and fx squared. So we have the total value of fx and x squared and fx squared. So we can use the summation of these values, and we can substitute it in the formula to get the mean, mode, and so on. So the mean, I get 35.04. So our mode is 30 because the frequency, it has the biggest frequency, which is 9. And our measure of dispersion is variance. Variance is summation of fx squared divided by summation of f. So we substitute the value. So the answer is 1458.92. So the next, we find standard deviation. Standard deviation is the square root of the variance. So we get 38.196. Next, we find coefficient of squareness. Alright, the formula is 3 multiplied by mean minus mode divided by standard deviation. So we just substitute the value that we get just now. The answer is 0.3956. Since the COS, which is coefficient of squareness, is positive, thus the distribution is positively skewed. Based on the box plot, the yellow one is the bigger than grey one, so that it is positively skewed.
Hi, my name is Mazudi. Now I'm going to present our histogram entitled How many times students of KMKu use WhatsApp in a day? For this data, we asked around 48 students about how many times they have used WhatsApp in a day through this survey. Soon, after they finish answering the question, the raw data is achieved and we tabulate them to gain the clearer view. Based on the tabulated data, we constructed a histogram which has 5 classes, starting from the range 0.5 to 2.5 and continue until 8.5 to 10.5. Notice that in the histogram, we use a class boundary and the class pitch, which is denoted by the capital letter of C, that is 2. To make it easier to calculate mean median, mode, and variance, we make another table to list out the midpoint, which we call x, the frequency, and cumulative frequency, lower boundary, and the other. Next, we use the information from the table to find mean by using the formula to find mean. We divide the total product of the frequency and the midpoint of the class with the total of the frequency. Finally, the mean we obtain is 6.5. From this finding, we understand that an average for a student of the KMKu use WhatsApp is about 6 to 7 times a day. Then, we also find the median from the histogram. By using the median formula for the group data as shown, the value we obtain for the median is 6.289. After that, we proceed to find the mode for our histogram by using the formula of finding mode. The D1 is the difference between mode class frequency and the previous mode class frequency, while D2 is the difference between mode class frequency and after mode class frequency. The C stand for the class width, which is 2. The mode we obtain is 5.75. It means that the highest number of times students use WhatsApp in a day is about 5.75 times. Lastly, we calculate the variance for our histogram by using the formula shown. The variance value is 5.28, and since the variance is quite high, our data is highly spread.
We've decided to construct an ogive. Note that our ogive is a less than ogive, because the ogive started with 0. In order to construct an ogive, we first need to analyze the data obtained. In order to do that, we can construct a table. To construct an ogive, we need upper boundary of the interval and also the cumulative frequency. How do you obtain the upper boundary? We can obtain it by averaging the upper limit of a class with the lower limit of the next interval. In this case, for example, we can obtain the upper boundary of the second interval by subtracting 61 and 60 and then divide it by 2, which will get 60.5. And also we can analyze the mean, mode, median, variance, standard deviation, and coefficient of variation from the data obtained. Group data must have interval. Here we have mean. Mean equals to summation of fx divided by x. In the end, we'll get 134.3. For mode, we'll be using the formula lower boundary of our class mode plus with the difference between the frequency of class mode with the frequency of the previous class divided by difference between frequency of the class with its previous class plus with difference between frequency of the class with its next class multiply with class width, and then we get 222.5. Median, first need to determine where does our observation lies in. So in our case, it is in the 25th observation. Therefore, we also be using the appropriate formula. Then we'll get 156.5. For variance, get 4663.8367. Standard deviation is the root of variance. We get 68.2922. Coefficient of variance is mean over standard deviation times 100, and in the end we get 50.85. So for me, thank you.